In section 4.4, we're going to take what we know about graphing and we're going to apply it to slope-intercept form. All right, so we're going to start with our key ideas. Now there's a lot of them here. They're not particularly difficult, but there's a lot of things to go over and remember. So let's look at our first key idea, X-intercept. Now, intercepts in general, think of interception. Interception in football is when the other team would come in and intercept the ball from the offense. Now, X-intercept, it's the same premise. The X and Y-intercept are where the graphs intercept the either Y or the X-axis. So the X-intercept of a line is the X-coordinate of a point where the line crosses the X-axis. Now, it's important to understand this, and I want you to underline this or put a star next to it. It occurs when Y is 0. The X-intercept right here, A, comma 0, that's the ordered pair. The X-intercept is A. The ordered pair is A, comma 0. So, when Y is 0, the X value, the X coordinate, is your X-intercept. Now, when X is 0, that's how you find your Y-intercept. So your Y-intercept in this case is B, at the ordered pair 0, B. So the Y-intercept of a line is the Y-coordinate of the point where the line crosses the Y-axis. So the X-intercept is when it crosses the X-axis. The Y-intercept is when it crosses the Y-axis. X-intercept, X-axis, Y-intercept, Y-axis. And it's where the opposite value, the opposite X or Y value, is 0. Now, slope-intercept form. Now, I'm hoping when you look at this, you realize slope-intercept form means I have the slope and the intercept. A linear equation, it's a linear equation written in the form y equals mx plus b, is in slope-intercept form. The slope of the line is m. The y-intercept of the line is b. Now it's important to know that slope-intercept form is when your equation is solved for y. Notice this equation has y equals mx plus b. M is the coefficient of x. That would be your slope. The y-intercept is b. It's important to know, and a lot of students make this mistake, that if I gave you this equation, let's say instead of y equals, I give you y plus 2x plus, let's do equals 7. The slope is not 2 because y is not by itself. Make sure you always note that this has to be, in order to be in a slope-intercept form, y has to be by itself. You have to solve your equation for y. Now we also have this study tip. This study tip says that linear equations can be, but not always pass through the origin. Obviously they can pass through the origin. That's when you have a proportional relationship. Or that's when you have direct variation, is when they pass through the origin. So proportional relationships are special types of linear equations in which b is 0. So if we're looking at like b, if b is 0, that's when you get your y equals mx or your y equals kx. In example 1, we have to find what the slope and what the y-intercept would be. And in order to find it, we have to identify slope-intercept form. So we're going to start with A. You'll notice here that in A we have the equation y equals negative 4x minus 2. We want to find the slope and the y-intercept. So y equals mx plus b is our slope-intercept form. Y equals negative 4x minus 2 is our equation. So in this case, the problem is already in slope-intercept form. So the slope, which is m, is negative 4, and the y-intercept is negative 2. That's it. Pretty easy. So we're going to look at example B right here. Example B, we want to find the exact same thing, the slope and the y-intercept. Here's the problem. The The y is not by itself. You must solve the equation in terms of y. So I would have to add 5 to both sides. That would give me y equals 3 halves x plus 5. Now you also could have 5 plus 3 halves x. You just have to make sure you note that the coefficient of x is your slope. In this case, the slope is 3 halves. The y-intercept is 5. So let's do another example. 3x minus 2y equals, let's do 7. This equation is not in slope-intercept form, so we have to put it in slope-intercept form. Step 1, we have to use the subtraction property of equality to subtract 3x on both sides. You are then left with negative 2y equals, now I know that it's 7 minus 3x, but we can put the negative 3x first and put it negative 3x plus 7. The next step is the division property of equality. I have to divide everything by negative 2, and so that would give me y equals positive 3 halves x, because negative divided by negative is a positive, minus 7 halves. So my slope would be positive 3 halves. My y-intercept would be negative 7 halves. Example number 2. We're going to graph using slope and y-intercept. So in example 2, we have the equation. Y equals negative 3x plus 3. And it says to identify the x-intercept. So first thing we're going to do is just graph using slope and y-intercept. First question to ask yourself, is the equation solved for y? Yes, it is in slope-intercept form. So step 1, here's how you graph using slope and y-intercept. The slope in this case is negative 3. The y-intercept is 3. So what does that tell us? The most important thing first is to understand what are we looking at. Well, I know the slope is negative. So because the slope is negative, I know that this line has to go downhill. And when it goes downhill, it's going to cross, remember this is the y-intercept, so it's going to cross the y-intercept at 3. I'm sorry, the y-axis at 3. So here's the y-axis. We know it crosses at 3. So that's where you start. You know there's going to be a dot on the graph at 0, 3, because that's the y-intercept. Now, from that point, your slope tells you which direction we need to go. But more importantly, we have to make sure we understand that slope, remember, is rise over run. So the rise, this is just a number. So we have to actually write this as a fraction, as a ratio. Negative 3 can be written as negative 3 over 1. Because it's negative 3, we're going to go down 3 spaces and write 1 since it's a positive 1. So, down 3. 1, 2, 3, write 1. So my next point is going to be right here. If you wanted to follow that trend, you could follow it. Make sure though, I can't tell you how many times I see students accidentally going down 3, left 1. Now if it was going left 1, the line would be going uphill, which can't happen because your slope is negative. So make sure when you analyze a graph, you take the time and realize, okay, what's my graph doing? What are the characteristics of my graph? Now the second part is identify the x-intercept. Well, the x-intercept is where it crosses the x-axis. Well, it crosses the x-axis right here at the point 1, 0. So the intercept is 1. So let's do one more example. Example B. Y plus 1/2 x equals negative 3. Step 1. Is it solved for y? Is the equation in slope-intercept form? No. So I'm going to subtract the 1/2 x. And that's going to give me y equals negative 1/2 x minus 3. The slope is going to be negative 1/2. The y-intercept is negative 3. Step 1, we know it goes downhill and crosses through negative 3. So here's negative 3. But let's say you're going to run out of room on your graph. Here, negative 1/2. The rise is negative 1, so we go down 1 space, and write 2. Now here we have room on my graph. But let's say you're like, oh, I didn't make my graph big enough. You can go the opposite way. You could go up 1, left 2. Now you're thinking to yourself, how can I go up 1 when it's a negative? Because watch what happens. If I put my negative on the bottom, the positive 1 tells me I can go up 1. But negative 2 tells me go left 2 spaces. So it doesn't matter if you follow going up and then left or down and then right. It should be the same thing. The most important thing is make sure you ask yourself, does the line go downhill? Does it match your slope? And it does. Our line goes at a ratio of a slope of -1/2 and crosses at -3 on the y-axis. Now obviously I want you to use a ruler. As you can see when I drew this, I kind of made the mistake of not going through the point. Make sure you, on the other hand, use a ruler, connect it to make it look like an appropriate line. Example number 3. The cost y in dollars of taking a taxi x miles is y equals 2.5x plus 2. Graph the equation. Interpret the y-intercept and the slope. Interpret. I love interpret because I want you to tell me what it means. The first thing we can do is write down what our slope is. Our slope is 2.5. Our y-intercept is 2. Now we have to write slope as a ratio, so you could write it as 2.5 over 1, or since 2.5 would be 2 and 1/2 as a mixed number, you could also write the slope as 5/2. That would be okay. So let's graph this. Because I'm talking about dollars, which is y, and x, which is miles, I only need quadrant 1 because everything has to be positive. So x and y I label. I also label my axes. So I'm going to start at 2, so I'm going to actually make my lines here. Obviously, graph paper is the best thing to use. So if I start at 2, I know my graph starts at 2, which is right here, my y-intercept. From there, my slope goes up 5, right 2. So up 5, 1, 2, 3, 4, 5, right 2. Now when I graph this line, you are going to note that I'm not going to draw an arrow going downhill on the left. The reason is because we're talking about positive number of miles and dollars that are positive, so there's no need to go to the left. So I graphed it. More importantly, interpret it. What does your slope mean? Your slope is 2.5, also known as 5/2. What does that mean? Here's the best thing I love. I love when students see this. You know that change in y is what slope is on top. Change in x is the bottom. What's your y label? It's dollars. What's your x label? Miles. So your label is dollars per mile. So what does your slope of 2.5 mean? It means the cost per mile. So the slope says $2.50 per mile is what the taxi driver costs. Now the y-intercept, it's right here. What does that mean? I automatically am starting at 2. It's the starting price. So it's an initial fee. So the y-intercept means an initial fee of $2. And that's what we're talking about. An initial fee of $2, and for every $5 increase, you can go 2 extra miles. $5 increase, 2 extra miles, otherwise known as $2.50 per mile.